lots of seniors in here. Tomorrow is our work keys day. We're going to take that work keys test, get it out of the way. So you should have received emails for that by now. So we'll see a lot of you in person tomorrow. Juniors, you get to stay home. Seniors, you'll be up here. Freshmen and sophomores will be up here too. They'll be doing like Atlas testing or something like that. But we'll get that work keys out of the way that the state says seniors have to take the work keys. All right. Well, we're going to get that done there. Last year, we didn't do it till April. So you guys were getting it done earlier this year. Get that out of the way so you don't have to worry about that. You can just focus on graduation then and move right on. But yeah, that'll be tomorrow. So coming up very quickly. Must be getting close to the end of the year. We got all this stuff going on now. I'm sure that doesn't make anyone mad that we're approaching summer. Goodness, we're approaching spring break in a hurry. It's like we got this week, we got next week, and woo, then we got a week off. So not going to be upset about that. So, oh, by the way, see, today is next Tuesday. I actually have a doctor's appointment in Little Rock, so I will not be here. So I will leave a video in Google Classroom for you to watch for attendance next week. So I don't think that we need to have a mandatory Thursday class the week before spring break because most of this will be pretty self-explanatory that you can get to it. We're going to start with some Khan Academy stuff now this week. And so since you have that next week, I think that'll be great. You won't need me to teach you that. So I'll leave it like as an ed puzzle or something so I can give you credit for watching it. That way I know who all's watched it and I can give you attendance credit for being in class, quote unquote. So, all right. All right. I think we are ready to get started. We've got 11 of us here. That's not quite everybody, but by golly, it's real close. So let's get this going up on the screen. Let's go to our grade screen as usual. Get started here. Let's see. You should be done with Module 5. You should be done with Module 6. Last week we had the Module 6 exam. So anyone that hasn't yet taken that, you're behind. You need to get that done very soon because we are moving on to Module 7, Matrix Operations. But yeah, you should be done with all of Module 5, all of Module 6. So if we look at matrices, we have 3 things due this week. These are very short assignments. We have 3 of them due this week. We'll have 2 due next week. Then we'll have a spring break. Then we'll come back and hit it hard, like 5 and 4. You know, so we're gonna hit it really hard after spring break. But we're gonna be in matrices all the way into April. So we'll have a bunch of lessons there in April. Get out of that, finish up, because we don't have much left of school after April. You guys going to run out of time here. So 3 things this week. So let's go to look at the matrices activity screen. Module 6, you can close that folder up. We're through with that. We're ready for Module 7. All right. When you go to Khan Academy, here, let's look at this. Intro to Matrices. So here's our first 2 assignments. You see they have the different icon. And then we have this assignment here. This is the 3 assignments we have due. Intro to Matrices folder and the representing linear systems. Okay, so this is what's due this week. If you can't remember what's due this week, always go to the grade screen, or you can go to Google Classroom because I list these 3 assignments. It's there. But we're going to look at the Intro to Matrices video, the lesson. We'll look at these 2 assignments. Then we'll look at this linear systems lesson and that assignment. And that's what we have this week. So when you click on this, it'll give you a link because Khan Academy is going to be providing our lessons for matrices. All right, Intro to Matrices.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of three. I guess we could call the three movies combined the Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So for example, this right over here, if I have 1, 0, -7, pi, 5, and I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has two rows, and it has three columns. And because it has two rows and three columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has two rows. So you see the two rows right over there, and they're telling you that it has three columns. You see the three columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has one row, one column. I could have a matrix like this, 3, 7, and 17. What is this? Well, this has one row. This is the one row we see here, and it has three columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has three rows. So it's three rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix. 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program or you're trying to do an economic simulation or a probability simulation to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation, and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
Basically, matrices are rows and columns, always rows first. We could have a 3 by 4, would have 3 rows, have 4 columns. So that's the important thing to understand is how to discuss what a matrix is. It's going to get important when we get to multiplying matrices and stuff. Algebra 2 has been doing matrices for the last few weeks. We added that as an Algebra 2 thing this year. They're not going to get into it as deep as you guys. We're going to go farther in matrices than Algebra 2 did. But Algebra 2 has been using matrices to bring their grade up. Like we got these 3 assignments this week. They're worth 20 points each. And it's just 4 questions. And it's really pretty simple as long as you're paying attention with these lessons and videos to understand matrices and how they work. So use this as a good opportunity to raise your grade here as we get into that. We get to after spring break, it gets a little more complicated, but as long as you understand before spring break matrices stuff, it won't be too bad. So, all right, let's look at the next lesson. Here's the lesson that goes with the video. We just saw the video. We click on this, it'll take us back to Khan Academy again. We can close this little half tab on the left side because that just gets in our way there. Right now, I've only released assignments for the middle of April, but Madison, there you go. Okay, it starts out with these lessons reminding you what a matrix is, because we just saw this in the video, 2 rows, 3 columns. So this is a 2 by 3 matrix. So that's the thing I want you to make sure you understand. It's going to mention that over the next several lessons to remind you how matrices are named, what their size is. This is matrix A, and it's a 2 by 3. All right, so in contrast, here's matrix B. This is a 3 by 2. See the rows, 3 rows, but only 2 columns up and down. So you could have a 2 by 3, you could have 3 by 2. Matrices can be all kinds of sizes, but they're always rectangular. And what I mean by that is if there's 2 columns in row 1, there has to be 2 columns in every row. There's not going to be one row that only has 1 or one row that has 3 columns. It always has exactly the same number of columns in every row. All right, so now we have some here. I'm going to open up the chat so I can get some participation from this. What are the dimensions of matrix D? All right, I'm looking in the chat there. Tell me what size matrix D is here. Mackenzie's on it quickly. All right, Piper says that. Kellen, everybody saying it's a 4 by 3. Samuel's got it. It is a 4 by 3, right? 1, 2, 3, 4 rows, 3 columns. We can see that. We'll hit the check. Perfect. So these lessons do have all this check your understanding in. If you go through these on your own, it will have these little things here where you can make sure you understand before you get to the assignments. What is the dimensions of matrix E? 2 by 4, 2 by 4. I see a 2 by 4. There are 2 rows and 4 columns. There you go, 2 by 4. 2 by 4. What about F? Oh, let's get a little tricky here. F is a 3 by 1, right? Yeah, there's 3 rows, 1, 2, 3, and there's only 1 column. You guys got this. You guys are quicker than the Algebra II folks. You got it. Now let's talk about the elements. Each of these numbers inside the matrix is an element of the matrix. So we call them matrix elements. And we can name those. Like if we look at number 18 here, they've got it highlighted. See, the number 18 is in the second row. They've highlighted that in blue. And it's in the first column. So that can be named G2, 1. 2, 1. So I would just say, look at matrix G, go to the second row in the first column. And what is 2, 1? It's 18. That's the number that sits in that position. So we can number and name any element in there just by its row and its column. So now they want to see if we understand that. Look at this one right here. Check your understanding. A13. Which element is A13? Which number are we talking about? Oh, you guys are quick on this. Yeah, the first row, third column, that's got to be the number 8 there. B21. Yeah, just because there's decimals on here, it's just a number. All we have to do is look at the second row, first column. We see that 4.6. Oh, which one of these? This is a little trickier. I like this one. Matrix C is a 2 by 3 matrix where element C12 is 6. Which of those, A, B, C, or D, could be matrix C. Now I'm seeing you guys are on top of this. Everyone so far thinks it's this one. Anyone disagree? So let's see. Does this meet all the requirements? It's a 2 by 3. So this is 1, 2. This is the 3 by 2, and this is the 3 by 2. So we can already eliminate A and B because they're not a 2 by 3 matrix. These are both 2 by 3 matrices. So it meets that requirement. C1, 2, first row, second column is 6. First row, second column, it is 6. Absolutely correct. Good job. See, they did the 2-1 right there to try to fool you. You were not going to be fooled. Okay, that's the end of that lesson. So that's the lesson that shows us what matrices and elements, how they're labeled. All right, so going back here and looking at that, those are the video in the lesson for the intro to matrices. Now let's look at our 2 assignments and let me show you how to turn these in. When we go to matrix dimensions, there's some instructions here. First of all, make sure you're logged in when you go to Khan Academy, because if you forget to take a screenshot, Khan Academy will keep track for you of what your scores were. So make sure you're logged in when you go there. After clicking on the link below and doing the problems, you're going to take a screenshot and then scroll down. I'll show you what I mean. Let's go to matrix dimensions. Let's go to the assignment. Again, it's going to take us to Khan Academy where this assignment is. I'm going to close that little half tab. All right. It says ready to practice. Show us what you can do. 4 questions. Notice I'm logged in because my name is up in the corner. You can always look at the top menu bar to see if you're logged in. Let's go. So it does 4 questions. I'm going to do 4 questions here. What are the dimensions of this matrix? Oh, that's a big one. That's bigger than the ones we look at. But still, it's just counting. We're back in first grade counting here, right? So I've got 1, 2, 3, 4. There's 4 rows. 1, 2, 3, 4, 5. I've got 5. And by the way, everyone's questions will be different. It randomizes questions. So yours may not look exactly like this. And then when you hit check, oh, look, good work. We got that one right. So now I go to the next question. What are the dimensions of this matrix? Well, this has 1 row and 3 columns. Next question. What are the dimensions of this matrix? This has 1, 2, 3 rows, 1 column. And finally, the 4th question. Okay, well, I don't know what you're doing, Khan Academy. Okay, we're going to assume, let me just show you how to do this. After you got all 4 finished, you're going to take a screenshot of your score because it'll tell you how many you got right. They'll say, congratulations, 4 out of 4, right? So then I'm going to take a screenshot. So I've got my screenshot. I'm going to go back to Buzz. Now this says scroll down. If I scroll down, oh, look, there's where I could put my screenshot. And this will have my score, 4 out of 4. And then I can submit. So I submit my screenshot right there of what I got in Khan Academy. Oh, did it come back? Oh, it finished. Oh, it missed my last. It's got 2 of 4. It's back on number 2 of 4. So it messed up early. 1 by 3. Check. 3 by 1. And, oh, this has 4 rows. 1. Show summary. There's where you're taking a screenshot. Say, look there, I got 4 out of 4. So let me take a new screenshot. There it is, 4 out of 4 correct. That's what you want to see, right? You want to have a really good score. 4 out of 4. If you don't get 4 out of 4, go back and do it again. You can go back and click on the link and go back to it and do it again if you want. So let's see, can I delete that? I can delete that one and replace it. Say 4 out of 4, resubmit. I'm submitting it again because I did better now. But that's how you turn it in. You take a screenshot right there. Again, since you're logged in, though, it should keep track of it. If you forget the screenshot, you can go back to your account and look and find your score for matrix dimensions. All right, so that is the first assignment. The second assignment is the matrix elements that we've also looked at. Again, you scroll down to turn it in, but when you click on this, it'll take you back to Khan Academy again, assuming Khan Academy is being nice. And you'll have 4 more questions about elements. I'm not going to do all 4 of these, but I'll just show you the first one now. Let's go. It wants to know 4-1, A41. 1, 2, 3, 4. The first one, you put -5 in there. Nice work. So we do 4 of those. Take a screenshot of that, paste it there. Yay, look, I got it all done. 4 out of 4, submit my work. Okay, let's go back. Okay, so that includes the intro to matrices. I'll go ahead and close that folder since I did all the assignments in that. Here's the other ones we have this week. We have one more lesson to look at, and then one assignment that goes with that. So let's look at this lesson. Now that Khan Academy is being nice again. Appears to be working. All right. Remember at the beginning, I said it always reminds you what a matrix is. 2 rows, 3 columns. This is a 2x3 matrix. But let's talk about how we can use matrices to represent a linear system of equations. Let's say we have this system of equations right here. I think I can make this a little bigger, just so it's easier to see on your screen. System of equations, 2x plus 5y equals 10, and 3x plus 4y equals 24. Remember when we solved the system of equations, we could use substitution, we could use elimination. You know, we would try to create a +2 and a -2x or whatever, and would add them together to get rid of the x's and solve it for y and all of that kind of stuff. Well, you can also solve systems of equations using matrices. So this lesson is just how do we convert systems of equations to a matrix. So look at this right here. It's color-coded. If we have this system of equations, this top row represents equation 1. Now notice the x's and the y's and the pluses and the equals, all that went away. We just are using the coefficients. We're taking the 2 from the x and putting it right there. We're taking the 5 from the y, putting it right there. And we're taking the constant, the 10, and putting it in the last column. So this first column represents the x variable. The second column represents the y variable. And then the third column is the constants that are on the other side of the equal sign. So this matrix represents this system of equations. 2, 5, 10, 3, 4, 24. All right, now we'll see if we can do this. Which one of these, we only have 2 choices this time, which represents this system of equations? 2x plus 3y equals 8 and 5x plus 2y equals 2. Is it A or is it B? Which one of those matrices? Mackenzie says it's B. Well, the first row is the same, right? 2, 3, 8, 2, 3, 8. And that's a 2, 3, 8. The only thing that's different is the second row. This one's 2, 5, 2. This one's 5, 2, 2. Well, if we look at our equation, we have 5 x's. So that x column should have a 2 and a 5. This one has a 2 and a 2. 2 and a 5. It does look like B. The y column should have a 3 and a 2. This first one has the 3 and a 5. They switched the x and the y. So that one's wrong. Correct. All right. How about this one? This one, we have to write it ourselves. What numbers go in the first row of this matrix that's going to represent this systems of equations? Mackenzie's got it. Anybody else? Samuel's got it. He's on it. We just take the coefficients, put them in the proper column. The first one is the x column. The coefficient is a 7. Then we have the y column. That's a 4. Then we have the constants. That's a 3. All right, good job. Second row. Again, this is the x column. 6, 3. Good job. You folks are on it there. Check. Absolutely correct. Just telling you, it's going to get a little trickier. Let's look at another example. What if we have 3 variables? Here's a 3x minus 2y equals 4, and an x plus 5z equals negative 3, and then a third equation, negative 4x minus y plus 3z equals 0. Well, remember what we said about matrices is they're always rectangular. Every row has to have the exact same number of columns. Well, this equation doesn't have the same number of variables. This one has 2 variables. This has a different variable, 2 variables, and this has 3. So if we look at the coefficients, we have to add in to where they all have 3 variables. 3x minus 2y plus 0 z's. There's no z's in that first equation. So we put the 0. There's no y in the second equation, so the coefficient of the y must be 0. So we can make a matrix like this. 3x, negative 2y, 0z equals 4. 1x plus 0y plus 5z's equals negative 3. And then the last equation had all 3 variables, negative 4x, negative 1y, 3z's, and it equals 0. So each column still represents all the x's, all the y's, all the z's. It's just we had to fill in some zeros when those were missing from the equations. All right, so let's see here. A or B, which matrix, this is where it's getting trickier, guys. Which matrix will represent these 2 equations? Samuel says it's A. Well, let's see. The first row is the same in both of them. 3, negative 2, 1, 5, 10. 3, negative 2, 1, 5, 10. And we see in the equation 3w minus 2x plus 1y plus 5z equals 10. But the second one, we have w plus 2y minus 4z equals 5. So there's a difference there. It put the 0 second or it put the 0 first. Well, which column is missing? The x column. That's the second one. This is the w column. This is the x, the y, the z. So it should be A because that is the one that's missing from the second equation. Check. Absolutely good. Good job, guys. Oh, we have to write this one now. We're about to get to a challenge problem, by the way. Just let you know. About to get a challenge problem. Okay, if we write a matrix to represent that system of equations, what numbers are going to go into our first row here? Samuel's got it. He says negative 1a, so negative 1, and then 1b, and then negative 2 is in the C column, and 12 in the last one. So let's fill those in. Here's Samuel's answer. So Laura agrees. She says, yep. Mackenzie agrees. All of you got the same numbers. How about our second row? Gets a little trickier on the second row because we've only got 3a plus b equals negative 8. You guys are not going to be fooled, are you? We have 3 A's. Second column represents the B's. We got 1B. The third column represents the C's. Well, there are no C's in the second equation. And it equals negative 8. Check. Fabulous. All right, challenge problems. Let's see. There's which system's represented by the augmented matrix. So this time we're going to give you the matrix, and you have to figure which systems of equations it's representing. Oh, that's a little trickier. We're reversing it on you. Is it the first three equations or the second three equations? A or B? Well, looking at the equations, the second and third equations are the same in both choices. The first equation is the only one that's different. Oh, see some of you guys choosing B. I think it's that one. We have 1, 0 in the first column. The first column represents the x's because we see x, y, z, x, y, z. So the first equation must have 0 x's. Well, this one has an x. That has -3. This one has a y and a z, no x's. So I think you guys nailed it. Correct. Okay, I think this is our last one. All right, which one of these, A, B, C, or D, represents this system? Samuel's taking a shot at it already. This is a challenge problem right here because this one gets a little tricky. Okay, I've written this down. I'm seeing a couple of C's. Anyone else left in class besides Alora? I know Alora's here, Mackenzie and Samuel. Everybody else go get breakfast or just stay in class? All right, so far you guys are choosing C, and you look at this, and some of you may be going, it's 3, -12, -2, but that's not what I'm seeing up here. And this is -2, -8, 15, but that's not what I'm seeing up here. Here's the key to it all, guys. I'm gonna put this up. I wrote this down. If we're going to convert this to a matrix, it has to be to where our matrix has, like, let's see what do we have. We have x's and y's only. It should have an x column and a y column, and then your constant column. Right? It's got to be in that order. These equations are not in that order. We have to rearrange them. So 3x plus 2 equals 12y. Well, the constant should be over there. Let's move that. 3x equals 12y minus 2. The y should be over here. Let's move that. 3x minus 12y equals -2. Now it's in the proper order. So the x is a 3. The y is a -12. The constant is a -2. Notice how that varies. This was a +2, and this was a 12y, but they weren't in the right place. After we rearrange them, we can get the proper numbers. Same thing with this. This is not in the right order. -8y equals 2x plus 15. The x is on the wrong side. So the x goes first, and the y. So now we can pull the numbers for our matrix. Now the coefficients will be -2, -8, and 15. Again, we had an x up here, but it was on the wrong side. So the numbers are wrong. So 3, -12, -2. 3, -12, -2, -2, -8, 15. You guys are on top of it. Good job. Not being fooled. That is correct. But you have to rearrange it if it's not in the proper standard form of an equation. And that's the end of that lesson. So you have one assignment to go with representing matrices. Again, make sure you're logged in. You'll scroll down and post your score here. Let's see what the assignment looks like on Khan Academy. Ready to practice. we're writing the equation. Writing the matrix for the equations. 5, 5, negative 15, 9, 10. And the first one's in the right order, X, Y. Good job. All right. Pick which matrix represents the systems of equations. So that is the assignments. That's the assignments. You'll copy and paste your score. And then this is next week's. Elementary matrix row operations. That's next week's. Don't worry about that. Just do intro to matrices and representing linear systems. So this is what we're doing this week. You see the icon for the assignments right there. And we're good. All right, guys. Any questions? Hopefully that looked very simple. You'll be able to just blow through these, get 100% on 3 assignments. Let's raise the grade. If your grade is suffering, matrices should be a good chance for you to boost that up, because this was real simple today. Counting rows and columns, counting. So, and then just pulling the coefficients off. So, all right. If you don't have any questions, guys, I'll let you go. You can probably have this done by the end of the class period before your next class comes. So have a great week. I'll see you seniors tomorrow. Work keys testing. It'll be a good day. We'll get that out of the way. See you guys.